Good afternoon, class. Today what I'd like to do is to go over atomic symbols and how to look at a element on the periodic table and figure out a lot of information on it based on where the numbers are in this. So in this example, I'm using hydrogen. Now as you can see, I've got a green box, a blue box, a black box, and a red box. And I put a little legend over here that tells you what each of them means. So to go over it, a green box is the isotope number. It is the number of neutrons and protons in this atom. So, for example, in hydrogen, you would have two, one proton, one neutron. That would be the second one. This is also known as a nucleon, which you've seen in your other chemistry vocabulary. Next is the blue box, which is the atomic number. This is simply the number of protons. This is important because protons, as you recall, are what give each atom their characteristics. So if you change the number of protons, you change the atom itself. Versus if you change the number of nucleons or the number of neutrons, all you do is change the isotope of the atom. For example, carbon-12 versus carbon-14. Next, you've got the red box, which is the charge number. That is the number of electrons more or less than the number of protons. This number can be positive or negative. It all depends on whether the atom has gained electrons or it has given away electrons. Hydrogen doesn't necessarily have a charge number, but usually, especially in an acid, what will happen is it will gain a +1 charge because its one electron generally will get ripped away from it or taken away from it. So it'll lose that electron, so it'll go away from it. And so that number will be given by a 1+. Usually, however, we don't write the 1 just like we do in math. You don't write 1 times something. So this one is usually will be written as H+. Finally, we have this black box, which is the number of atoms in the compound. So for example, with hydrogen, this number would usually be a 2 because in nature, hydrogen is found, it pairs with itself. So you would usually find hydrogen in nature as H2. So that is how to deal with atomic symbols. Good luck in your studies. And next time we'll focus on a specific example of it and how it relates to other chemicals and other compounds.